new mnemonic, okay, to help us remember which base pairs go together. Okay? We're just going to have a minute or two. Ready? Go. Do we have a question?
Another one?
We just remember A and T go together and C and G go together. This one should be a little bit simpler. Remember A and T together and B and C together. That's your challenge. Alright, let's share a few. Okay, who wants to share first? We have one here. Okay, everybody listen. Ants love tunnels, grandmas love cats. Perfect. Okay, another one.
Did alley cats and tigers and gators and crocodiles.
Perfect. Okay, one more. Okay, so I actually noticed this the other day too when I was sitting in the back of the room. I don't know if anybody else has noticed this over here. A-T-G-C.
Oh, mine. That's right.
Okay. So if that works for you, awesome. Okay. Mnemonics are all about finding things that you will remember. Okay. And so that's why it's so important for you to come up with something, because you're more likely to remember it. Okay. Last semester in one of my courses, I remembered dumb kings play chess on fine green sofas. Remember the classifications of organisms. Domain, kingdom, genus, species. Right? So it doesn't matter what it is as long as you remember it. Alright. Now, we're going to talk about bonds. Okay, we're going to talk about two bonds, very important. Covalent and hydrogen. Okay?
Like, we know this.
So I want you to turn to your partners again and explain everything you remember about these two types of bonds. Okay, ready, go.
Covalent is when they share. Yeah, covalent is when they share. Hydrogen is when they have When water is separately. It's like
Doesn't really matter.
Alright. What did we learn? Or what did we remember? What is a covalent bond?
They share.
Share what? They share electrons. Okay. In the spectrum of bonds, how strong or weak are covalent bonds? You know. Somebody raise their hand and go out on a limb.
Wait, what was the question?
So on the spectrum of strong bonds to weak bonds, where are covalent? Are they strong? Are they weak? Okay, so I'm hearing both. Okay, covalent are pretty strong bonds when we're talking about it. Okay, they're actually pretty much the strongest when we're talking about the main types of bonds. Okay, so what about hydrogen bonds? What do we know about hydrogen bonds? They're weak. That's very true. Okay, How does the formation of hydrogen bonds work? Okay, oftentimes it's in water. Does it have to be? No. Okay, usually it involves a hydrogen though, right? Hence the name hydrogen bonds. Okay, so you mentioned in water. Alright, I did that kind of small, I apologize for those in the back. My scale was not to scale. Okay, so in this, oxygen is a hydrogen, or is an electron hog, right? They love electrons. So they're going to pull the electrons towards it, creating an area of negative charge and an area of positive charge. Okay, this electron does the same thing. Or, sorry, that atom does the same thing. Okay, so you get this positive and negative that can then attract. Okay, so this is kind of the same principle with all hydrogen bonds. Okay, and so now we're going to see how these fit in to, there we go. Okay, so this is DNA. Okay, so we see hydrogen bonds here, right? And covalent bonds here. Okay, these specific covalent bonds are also known as phosphodiester bonds. Okay, because they're between phosphate groups. Okay. At least to me, it's more important that you understand that these are covalent bonds rather than you remember phosphodiester. Okay. So, we talked about bond strength. So, do you think that there's a greater attraction between the DNA strand going this way or the DNA strand going this way? In the back. What do you think? Why?
So we're talking about the strength of it?
Mhm.
Okay, yeah. This is, the ones on the straight up on the vertical are covalent bonds, the ones horizontal are hydrogen.
Right. So these ones of the strand are connected by covalent bonds, so they're going to be very strong bonds and hold very tightly together. The ones going this way, okay, between the base pairs, did anyone notice that? Base pairs? Okay. They're going to be much weaker because they're hydrogen bonds. Okay, so why is this important? Okay. Remember, we always have to ask the question, so what? Why is that important that the hydrogen bonds are there and the covalent bonds are there? Take a chance. Make a guess. We're all learning.
Yeah, because that's
No.
Okay.
Because they were falling apart, if it would be an outside, if that hydrogen bonds were like an outside, would it fall apart easier?
Right.
Like that.
Okay, so let's say, like what you're saying. So let's say these were hydrogen bonds.
Sorry, yeah.
What would you say would happen?
Like it would fall apart easier if the hydrogen bonds were an
They would
outside?
split this way, right?
Yeah,
Okay. And it would actually change our DNA. Okay. So why is it important that hydrogen bonds are here? What does that make it possible to do? We want these weak. So they can change. Okay, they do change quite frequently.
Does it just make it move easier? If the hydrogen bonds are on the inside and the hydrogen bonds are on the outside?
Okay, it does make it easier, but it's for a very specific purpose what we see. Okay, what happens, okay, if you want to make a new strand of DNA, okay, what's going to happen is you can think of this as a zipper. Basically, all these hydrogen bonds are going to unzip, and then new base pairs can be added to each. Okay, so if these were covalent bonds, could it unzip? No, you could never replicate your DNA. You could never make RNA, which you'll talk about later, and we're not going to talk about right now. Okay, and so it's critical that these strands stay together and these can unzip. Okay, so we have to understand that. All right. We're actually a little behind where I wanted to be time-wise, so we're going to have to really hurry. Let's see, do I need to talk about anything else? Let me talk about one other. Okay. You see the word anti-parallel up here. Okay, that's an important part of DNA. So, once again, you're only going to get 20 seconds, okay, to discuss this with your partner. What does anti-parallel mean?
You only use 5 seconds.
What do you guys think? Anti-parallel.
Parallel, we do it for second grade.
Just kidding, I don't get it.
But you have free
I think I'm thinking about
All right. What does it mean? Anti-parallel. Not parallel? Okay. What else does it mean? Cross. No, they never cross. You remember, it's like a ladder. It's a twisted ladder. The ends never cross. Not exactly the same.
Does it mean that it's not just, it's not parallel, but it never can be?
Not quite. Okay, so let's say I had a sequence, we'll say 10, 9, all the way to 1. Okay? And if we want to make something anti-parallel to that, we're going to go 10, 9, all the way to 1. So basically opposites from each other. Okay? That's very important to remember. Anti-parallel. Alright. So, I forgot. Okay, so now, like I said, we have to hurry. We're going to get into groups, and you're going to make a human DNA strand. Alright? So right here, I have 8 nucleotides. Okay, and it's going to go pretty implicit for you. Okay? Within your group, I want you to be able to show as many of those things that we've talked about the structure of DNA, as you can. Okay? So do you guys get it? So we're going to have necklaces, you're going to become...
Can we go back to the slide with like
You don't remember your mnemonics?
well, not the colors. Wait, does the colors matter?
No.
Oh, okay.
So let's clear that up, okay? Colors do not matter. Okay? It's just the letters that we're concerned with. Alright? So we're going to count off in groups of 3. Okay. Okay, count up. Ready? 1. 1.
Great.
Right, 2. Okay, everybody listen. We have to hurry. You're at 3. 3. Alright, all the 1s over here, all the 2s in the middle, all the 3s on this side. Okay, have one group member come pick up your nucleotide.
It's not a test.
So, group 2.
Group number 3 over here today, people.
Okay, you only have about 5 minutes. Yeah, one's over there. 2s are in the middle. Looks like we're missing some 1s.
Are we just like making a diagram, or do we have to make a...
No, this is a human DNA sequence. So you are going to nucleotides.
Oh, everybody gives
Or pretty much.
Are you guys 3?
With your nucleotide letter.
Come on, groups.
slacking on their phone.
And you have to figure out a way to represent. Maybe other things to talk about is you can't. If you might feel okay, how are you gonna represent the bond? How are you gonna represent? That's the one I'm really. Okay. Okay, raise your hand. What's going on?
Like straight or something.
Yeah, that one's like butter.
Okay, then tie it
Here,
like
let's-
this.
You ever cut it in half? Alright.
Alright, perfect.
Alright, let's figure out how you're gonna represent it.
Guess what?
4 minutes.
Okay, I'm an A.
Are you short one?
So find some.
So just like link hands, so it's like.
Okay. Are you guys